First, the sampling technique used is sample random sampling because a common approach to selecting a random sample n equal 50 where each data point have an equal chance of being included. Second, type of data. Type of data is quantitative data because representing numerical value such as labor, force, figure. For example, 13, 17, 20, and others. Last, level of measurement. The level of measurement is retro, as the data consumed of numerical value with a true 0 point that is zero labor force is a meaningful value.
To construct three appropriate tables that can be used to describe the data. So this is 50 sample data. 1.0 group data table. For class interval 13 until 44, the frequency 11, 45 until 76, the frequency 9, and 77 until 108, frequency 5, 109 until 140, frequency 11, 141 until 172, the frequency 6, 173 until 205, frequency 8, and the total is 50. Next, 2.0 relative frequency distribution table. Class interval 13 until 44, the frequency 11. For relative frequency 0.22, 45 until 76, frequency 9, relative frequency 0.18, and 77 until 108, the frequency 5, relative frequency 0.1, 109 until 140, the frequency 11, relative frequency 0.22, 141 until 172, the frequency 6. For relative frequency 0.12, 173 until 205, the frequency 8. Relative frequency 0.16. So the total for frequency 50 and the total for relative frequency 1. For class with 2k more than n, so n 50. So for 2k 64. So 64 is more than 50. So k is 6. So for class interval or class width 2005 minus 13 per 6, the answer is 32. 3.0 cumulative frequency distribution. For class interval 13 until 44, cumulative frequency 11, 45 until 76, cumulative frequency 20, 77 until 108, cumulative frequency 25, class interval 109 until 140, for cumulative frequency 36, 141 until 172, cumulative frequency 42, 173 until 205, cumulative frequency 50. So the total is 184. So this is graph histogram. So this is table for graph polygon. Class interval -13 until 12. Midpoint -0.5. Frequency 0. 13 until 44. Midpoint 28.5. Frequency 11. 45 until 76. Midpoint 90.5 and frequency 9. 77 until 108. Midpoint 92.5. Frequency 5. 109 until 140. Midpoint 124.5. Frequency 11. 141 until 172. Midpoint 156.5. Frequency 6. 172 until 205. Midpoint 189.5 and for frequency 8. So the total for frequency 50. Okay, this is graph polygon.
As for my part, to find a value for major center of tendency, this has 3 of center of tendency, which mean whether they have a table for class interval, midpoint and frequency, and relative frequency. As you can see here, this is the table for you to find mean, which is here the solution to find mean. 5,145 divided by 50, which means this is n for total of frequency that have, or total of sample. I'm sorry. This is the answer for the means. As for the median, as you can see here the table for the median, which is have class interval, frequency, cumulative frequency, and lower boundaries. Which is this is formula to find the median. So the median we can find on the class 77 until 108. So as for lower class boundary 76 and 5.5, and this is the solution to find the median. As for the mode, this mode only need this table, because to find the mode you only need frequency total and class interval. As you can see here, this is lower boundaries. We can see here the lower boundary for this is 140.5, and the class wise is, as we know, 32, and the difference of class model frequency and before class frequency. We need to find the data for like before frequency is 6 and after the class is 5. We can see here the data 6 plus 5, and yes. Okay, as for the mean zero position, we can see here the table for class, for the table class table, frequency, cumulative frequency, and lower boundaries. To find location for Q1, this example, formula to find Q1, which is sample need to divide by 4, because we have Q1, Q2, and Q3. Every Q1, Q3, we have part where the Q1, Q2, Q3, and Q4, but we need to divide by 4. That's why. Okay, for the location for Q1 is 12.5 by referring the location of Q1 on cumulative frequency column. Therefore, the class interval for Q1 is 45 until 76. So here you can see as for the solution to find Q1, which is 49.83. Therefore, Q1 49.80. This means that 20, 20, 20 to 20 25% of labor force in Malaysia, and most labor force less than 49.83 and 75%, and the labor force that work more than 49 and 53. After that, we need to find for location for QT, which is T and darab 50 divided by 4. We got 37.5. So the location for QT is 37.5 by referring the location of QT on cumulative frequency in the class. So the class interval is 109 until 140. This is the solution to find the QT, which is we got 100 to 20.61. Therefore, QT we got 100 to 12.61 of labor force on Malaysia, and most labor force are less than 120.61, and 25% of labor force are more than 120.61 labor force. As for class measure of position for quartile, to find location for Q1, you can see here for the formula, sample divide by 4, which is we have 4 quartile, quarter 1, quarter 2 and quarter 3, divide by 4 lot. For the table, we need class interval, frequency, cumulative frequency and lower boundaries. So the location of for Q1 is 30.5 by referring the location of Q1 on cumulative frequency column. Therefore, the class interval is 45 until 76. So the solution for Q1 44.5 plus 12.5 tolak 11. As for measure of variation, we can see here there's a lot table, which is we need 6 table here. So we need class interval, midpoint, frequency, Fs, S kuasa 2 and Fs kuasa 2, which is F for frequency and X for midpoint. We need to now. So we need to find, as you can see, as for variation, we need to find here the formula. So we've got 2968.65. So to find the standard deviation, we need to punca kuasa the answer, which is we got 55.48.
Part B. Given appendix number of apartment in city, randomly choose 200 numbers. The sample size of number is n equals to 40. Type of data. The type of data is quantitative data because representing numerical values such as number of apartments figure, for example, 11, 104, 61, 9, 118, 45, 24, 89, 42, 22, 123, 87, 37, 90, 52, 33, 125, 83, 43, 101, 81, 33, 114, 76, 23, 112, 67, 11, 92, 52, 30, 106, 78, 6, 91, 44, 12, 11, 111, 70, and 40. The level of measurement is ratio, as the data consists of numerical value with the true zero point, that is zero number of apartment is a meaningful value. The table show that independent variable and dependent variable For the independent variable is competitive prices, and the dependent variable is sales volume. The table shows the Pearson product movement correlation coefficient. In this table, I have competitive prices, sales volume, xy, x square, and then y square. The sum of the x is 2522. The sum of the y is 963. The sum of the xy is 82567. The sum of the x square is 213264. The sum of the y square is 321123. Given the calculation and R value, for the R value is 0.992. Interpretation of R value is the Pearson product movement correlation coefficient suggests a strong positive linear relationship between competitive prices and sales volume.
The next question is about the develop the estimate regression equation, then interpret the regression equation. So the question asks us to using Excel to show all the calculation and interpret the value. So this is the data of the number of apartments in the city from the Excel, and we got the total of x, the total of y, the total of x multiplied with y, and total of x squared. So first of all, if we want to develop the estimate regression equation, we have to find the slope and intercept. So first of all, we find the slope. So the formula of slope, or b1, b small 1, equals to total of x multiplied with y minus with total of x multiplied with total of y divided by n per total of s square minus total of s square divided by n. So the value of the total of xy, we got 82,567 minus with 2,522 multiplied with 963 divided by 40 over 21,364 minus with 2,532 square per 40. So we got the value of the top one is 21,849.85 over 54,251.9. So we got the total of the value of divided is 0.4027. For decimal places, it's a must. So the next we have to find the intercept. So the formula of intercept is equal to total of y over n minus the slope, the value of slope, the slope multiplied with total of x over n. So the value we got 963 over 40 minus with 0.4027 multiplied with the value of 2,522 over 40. We got the outcomes of to divide by the first 963 over 40. We got 54.075 minus with 25.390235, and we got the answer negative 13152. And we got the two decimal places. We got negative 1.32. So the simple linear regression equation, we got negative 1.32 plus 4.4027x. So we conclude that therefore the simple linear regression equation is competitive prices equals to negative 1.32 plus 0.4027 sales volume. So after that, we interpret the regression equation. So we got the regression equation competitive price equals to negative 1.32 plus with 0.4027 sales volume. And then we interpret. So we got intercept equals to negative 1.32, and we interpret with when competitive prices of apartments in the city RM X is 0, the sales volume Y equal to Rn negative 1.32 or Rm negative 132. The next one, we got slope equals to 0.4027, and we interpret the equation for every 1 unit increase in competitive prices of apartments in the city. Rm x the sale volume of apartments in the city, while Y will increase by Rm 0.07, 0.4027 units, or Rm 40.27 ringgit Malaysian.